Welcome to Homeschool High School Chemistry. I'm glad you're here. Let's get started. Today we're talking about what chemistry is and also learning to measure some things. So first off, chemistry is about exploring the things that make our world. If you break everything down into the smallest units possible, where everything's not exactly the same. So if you keep going down past the atom, which is what we're about to talk about, if you keep going past that, you get into protons and neutrons and electrons, but those are the same for everything in our world. If you go just a little bit further out, that's the atom. And that's really what chemistry is all about, atoms. And each atom is unique, and each atom has its own properties and acts in certain ways. That's what we're going to be learning about in chemistry. So what is chemistry? What ideas do you have about what makes chemistry chemistry? So how things work inside of living things, but also in non-living things. Non-living things also have to do with chemistry. So if you're thinking about geology, for example, and you're studying rocks, that has to do with chemistry. Describing those different pieces, you can describe their properties because the atoms that make them up do certain things. So geology has to do with chemistry. As a matter of fact, chemistry is in everything, every piece of everything that makes up our entire world. So chemistry is the study of matter. And matter is anything that takes up weight and has mass. You might hear that sometimes as weight. They're not exactly the same thing, but close enough. So think about the computer that you're using, or if you're using a phone, think about the desk that you're at, or counter in my case. Think about the air around you. You might not think about air as taking up space or having mass. We'll actually do an experiment later on where we'll show that it does. Air takes up space and air has weight or mass. So pretty much anything in our universe is made up of matter. The exception to that is energy. So think about light. Light doesn't take up space and it doesn't have weight, or heat for that matter. Things that burn, so a log or the fuel in a burner, that does, it's matter, but the heat itself doesn't take up space, it doesn't have weight, that's energy. So the two things that we really study in our universe are matter and energy, and chemistry has to do with matter. Energy is also involved, and we'll find out about that later, but matter is what we're talking about right now. Chemistry is the study of the fundamental building blocks of matter, which are atoms. So like I said, atoms are made up of protons, neutrons, and electrons. Those are all the same for everything, but how those are arranged within the atom, how many of them there are together, how they interact with each other, that's what makes each thing in our world different. That's what makes oxygen different than gold, for example, is how many protons and electrons there are in a given atom. That's what changes things from one type of thing to another type of thing. So chemistry explores atoms, which then can combine into molecules. Molecules can combine into compounds. And so we study not only the atoms and the molecules and the compounds, but we study how those interact with each other. So chemical reactions are different molecules interacting together. That's what chemistry is all about. Matter can exist in several different forms. It can be a solid, a liquid, a gas, and some other ones we'll talk about when we actually get to phases of matter. As important as that, though, is that matter acts in predictable ways. There are laws that means that we can know how two things are going to interact. If you've ever done an experiment before with vinegar and baking soda, you know that you put those together and you're going to get a lot of bubbles and lots of noise. That's going to happen every single time you do that because the way matter interacts is predictable. So that's what chemistry is, talking about how matter behaves because of the different environmental situations that are going on. So why does chemistry matter, do you think? Understanding chemistry helps us know how we can manipulate it in certain ways and also know how to deal with certain situations. So understanding chemistry means that chemists are able to create medicines that can help people, or they know to utilize salts that you can put out on the roads to melt the ice because they know how water is going to react in the presence of salts versus just as pure water. So understanding chemistry helps us interact with the world around us and in some ways control it and use it to better our world. Chemistry is also related to every other science, whether you're talking microbiology or anatomy or geology, like I said, or astronomy. Those all have to do with chemistry. You have to understand chemistry to be able to really understand those things. And so sometimes chemistry is called the central science because it relates to all the other sciences. As we get started with our chemistry class, you're going to want to have a chemistry notebook. This one is a composition notebook. I would encourage, if you're going to get an actual notebook like this, that you get a composition notebook, not a spiral bound one, because the pages on those tend to come out more easily. Or you could get a 3-ring binder and some paper to put in there, but you will need a science notebook. If you didn't get a chance to look, be sure to check out the link in the description. There is a link to the science class information sheet, and that will tell you what you need for the class in general. So it'll tell you that you need a science notebook and you need goggles if you're going to be doing the experiments along with me and different things like that. And then it'll also tell you for each lesson, what are the things that you're going to need if you're going to do the experiments with me, and also which PDFs I'll be using if you want to use the Layers of Learning PDFs. You don't have to, but they're there and would probably make your life easier. Instead of having to copy everything down. So grab your science notebook and we're gonna get it set up. To get started setting up our notebook, I want you to open up to the first page and I want you to write at the top, table of contents. We're gonna create a table of contents at the beginning so you can always find what you're looking for. So on your first page or on a separate sheet of paper, if you're using a 3-ring binder, write table of contents. Then after you've written that, I want you to turn 3 pages. So 1, 2, 3. That's going to be reserved for writing our table of contents on. So this next page is actually where we're going to start taking notes. So I want you to number at the top of each page. So 1, and we'll turn and do 2, 3, and so on. I want you to number the first 10 pages and we'll just start there. You can add more numbers as you go, but take a second and do the first 10 pages and then turn back to the beginning of your table of contents. So on your table of contents, I want you to write the number 1 for page number 1 and then write measurement exercise because that's what we're going to be doing today. Once you've done that, I want you to turn to page number 1. So you're going to turn past the pages that we saved for the table of contents to the page that you numbered 1. And at the top there, you're going to write measurement exercise. So every time that you take notes, I want you to give it a title. Sometimes I'll tell you what that is, sometimes I won't. But every day that we have a class, I want you to take notes, make a title, and then don't forget to put in your table of contents that same title so that you can go back to it and find it. So today's is measurement exercise because that's what we're going to be working on today. So now let's talk about what we're going to write in our notebooks. So once you've got the name written down, I want you to write the date. So if you wrote the page over here, write the date over here or vice versa so that you have both of those things. So as we take notes in our science notebook, you're going to put the title and the date, obviously the page number, and put it on your table of contents. And then we also want to write down the purpose for what we're doing that day. So today, during our measurement experiment, the purpose is to learn to use our measuring equipment. So right below the title, you're going to write purpose, and then beside that, you're going to write down to learn to use measuring equipment. So let's talk for a second about why we're even creating this chemistry notebook. So for one, I want you to keep notes of what we're talking about so you can have terms and important things that you learned so you can go back and remember them. But also, it's a practice that actual professional chemists do, and really all scientists keep detailed notes. And so some of the important things that they keep note of are what they're doing, when they did it, why they did it, and then our next piece, which will be observations. So below that purpose, you're going to write observation, and you're going to write down the things that you learned or you noticed as we did the experiment. Today isn't exactly an experiment. We don't have variables and things we're trying to figure out. So that's why I was calling it an exercise, but still you can write down things that you observed or important information that you learned. So for you as a student, as well as for professional chemists or scientists of any kind, their notebook is really important because they write down things for themselves to remember exactly why they did what they did, how they did it very specifically. And that allows also in the future for somebody to come along and take it and see if they can replicate what that person did. So if someone conducts an experiment and has detailed notes about how they did it, someone else can come behind and do the same thing and see if they get the same results. If multiple scientists get the same results doing the same experiments the same way, then it's pretty safe to assume that that procedure actually works exactly like it's supposed to. It also means that if something goes wrong, you can look at it and say, here are the steps that I took. Here's something I could tweak. If you don't know exactly what you did, then you can't tweak it. So you may not know where to go next. An important part of our chemistry class is going to be learning to take detailed notes. So we're getting started today. So as we get started and ready to do some measurements, let's talk about different types of measurements. You've probably done different kinds of measuring in your life. So you may have made a cake. For that, you need to measure the flour and the sugar and the vanilla. Maybe you have done experiments before and you've had to measure different ingredients for that. Maybe you've made a dress and needed to measure the fabric. Each of those is a different type of measurement. And so, for example, when we're making a cake, you may use a teaspoon to measure out how much salt you need, or you may use a liquid measuring cup to measure out how much water or milk or whatever it is you use to make a cake. I guess it depends on the cake. If you're measuring to make a dress, like I said, then you're going to use a tape measure to see how long something needs to be. So each of those is a different type of measurement. So we have different types of measurement in science as well. So first of all, we can measure volume. That's how much space something takes up. To measure volume, we can use a graduated cylinder like this. It has markings on the side that show how much liquid is in there. So this would be measuring the volume of a liquid. Or you can use a beaker that also measures the volume of a liquid, but a graduated cylinder is more precise. So it depends on what you're trying to do, which one you want to use. But these both measure volume, how much space something takes up. We also might want to measure weight. And to do that, we use a mass scale. This is an electronic balance or scale. That's what I'm going to be using today to measure out the weight of different things. You may have made a cake by measuring out and weighing ingredients, or you may just have used something like a teaspoon to measure out your salt. So it depends on what your recipe calls for and what equipment you have available. So today, as we're measuring things, if you don't have an electronic balance, I'll tell you how much with the measuring spoon you need to measure out. An electronic balance or scale will let us weigh whatever we're working with. To use an electronic balance, we need to have something that we put on it. So you don't want to ever put things straight onto your balance or your scale. So today I'm going to be using a watch glass, or you can use a bowl, just anything that you can put on there to put things inside. And we'll talk about exactly how to use the electronic balance here in just a minute. So you need your balance and then some kind of container to put on top of it that you're going to put your substance in that you're measuring. So that is for measuring weight. We can also measure temperature. And for that, you're probably familiar with a thermometer. It may not look like this. You may have a digital thermometer, one that you stick in your mouth if you're sick or something like that. You may have a meat thermometer or a candy thermometer, something like that. But a thermometer measures temperature. So that's something else that we can measure. We won't be doing that today, but we will be doing it in an experiment very soon. So as we go through these experiments, we will be measuring things in weight. Like I said, I will tell you how to use measuring spoons to get the same amount of a substance, but they're just not as accurate as measuring it with a scale. But I will tell you if you need that. So I would highly encourage you to get an electronic balance if you can. You can find them on Amazon pretty cheaply. I'll link to one in the description. But that's pretty important. And then a graduated cylinder. I will also tell you the measurement in a liquid measuring cup in case you don't have a graduated cylinder, but again, this is just more accurate. This is a 100 ml graduated cylinder, and that is the perfect size for the things that we're doing this year. But even if you don't have those, you will be able to complete the experiments. I will link to graduated cylinder and goggles and different things like that in the description, so be sure to check that out. There's some important terms that we need to understand as we start taking these measurements. So there are qualitative measurements and there are quantitative measurements. So if I tell you to get pasta water ready, so you're going to boil pasta, would you need to measure out the pasta water with a measuring cup and make sure that it's exactly right? Probably not, right? You just need to make sure that there's enough water that it'll cover the pasta and boil without boiling over in the pan and get it cooked without sticking together, right? It doesn't have to be super exact. That's what we call a qualitative measurement. That's when you don't need an exact amount. On the other hand, if we're talking about how much medicine you should give to a baby, the exact amount is pretty important, right? So that is called a quantitative measurement. So qualitative is like kind of a quality, we need a lot of water or a decent amount of water, kind of fill up the pot to about here. That's a qualitative measurement. A quantitative measurement is we need to know the quantity. We need to know the exact amount. So that's the difference. Those are pretty important terms, so you're going to want to write those down. So on the page where it says measurement exercise, you can write down those terms: qualitative measurement and quantitative measurement and their definitions. So another important term that you need to know is when we're measuring liquids, like in a graduated cylinder, you want to measure to the bottom of the meniscus. We don't know what that is yet, and I'll show you what that is in just a minute. So for right now, just write down measure at the bottom of the meniscus, and I'll show you what that means here in just a minute. The last thing that you need to keep in mind is that you always, always, always need to write down a label. So whether that is inches, grams, seconds, you need to write that down. So I won't be grading your work, maybe your mom will be, but in a science class, if you don't put down your labels, the same for math, then that would be counted wrong or at least some points off. And in real life, it can cause lots of problems. So if I don't know if you're talking about 2 inches or 2 centimeters, that's a pretty big difference. A lot of times by context, you can figure out the type of unit it is, but it can get really confusing if we don't know if it's grams or milligrams, if we don't know if it's ounces or grams. That's problematic. So always write down your units. So write that important information down in your notebook. Today we're going to be working on measuring liquids and solids, but before we do that, I want to make sure that you're familiar with the equipment that we're going to be using. So I have special equipment that I'm going to use. I'll tell you the things that you can use if you don't have those things, but I do want you to be familiar with those terms. So this is the PDF that I'm going to be using. It's from Layers of Learning. You can find the link to that curriculum in the description. You are not required to have that. It's just really neat. Their stuff is fantastic and will keep you from having to write a bunch of stuff down. I don't get paid anything for telling you to go buy it. I just love their stuff. So if you have that, go ahead and grab it. If you don't have it, you can pause the video, write these things out on a separate sheet of paper and use it like that. But I want you to grab that paper and you're gonna put it, you can put it on this front cover of your notebook because we're gonna use this over and over again. So you can tape it, glue it, staple it, whatever you want to, or if you are using a 3-ring binder, just 3-hole punch it and put it in your binder at the front. But that's something that we're going to use over and over again, so be sure that you have it handy. So I want to talk you through each of those pieces of equipment. We've already talked about an electronic balance, so that's the first one. I've shown you a beaker. So beakers are for measuring. They also give you a nice safe place to stir or heat things up. Now you have to be sure if you're going to put it on heat that it is one that's made for that. There are some that are plastic even. You don't want to put those on the heat. But these, if you buy them at a science tool supplier, just make sure that you read in the description that they are good for putting on heat. So that's this. I don't actually own a flask. You can see that on there. That's also for putting liquids in, measuring it, using it for different things. I do want to own one someday, but I don't have one quite yet. Other things that we won't be using today, but I want to show you. Here's my chemistry bucket, so I'll show you some of the things in here. This is a burner stand and a burner. So again, these are not things that you have to have. I'll show you alternatives, but if you want to buy them, Home Science Tools is a great place to put them. I can put links to that in the description for each of these items as well. But this is a burner and a burner stand, and that is for heating things up. We'll do an experiment here pretty quick that actually uses the burner stand, or you can do it on the stove if you need to. A funnel is also important. So this lets you put liquid or solid into smaller openings without making a mess. So funnel is important. We already talked about a graduated cylinder. That lets you measure things accurately. Another thing that is on there is a glass stirring rod. So a lot of times you can just use a spoon, but if you're trying to, let's say, get down into a test tube, that fits nicely in there to let you stir that. You can try the back end of a spoon or like a skewer or something like that to stir if you need to, or a lot of times you can shake it up. But that's what it's meant for, is to get into something like that, or into, let's say, the flask like I showed you. And then occasionally there are things that metal will react with. So this is made of glass and that doesn't react very easily with things. So that is actually helpful for things that would be reactive to, say, metal in a spoon. So that's what a glass stirring rod is for. I already showed you a test tube. So this is something that you can put liquids in, or powders or things like that, to mix together with other things, or you can put it inside of a beaker with some water in it, and that way you can put it over the stove, but it's just smaller in diameter, so it's easier to see and to work with and be more exact than in a bigger thing like a beaker. So that's for smaller quantities, and it lets you see the reaction a little bit better sometimes depending on what you're working with. Then besides that, we also have a test tube rack or test tube stand. So if I'm doing an experiment where I'm adding different things to different test tubes, I can put them all in my test tube rack and add whatever I'm adding to each of those as I go. And then once I've washed them, this one, not all of them are the same, but this one has spots for drying them by turning them upside down. So that's a test tube rack. Then I already showed you the thermometer. So this is a lab thermometer, a science thermometer. You don't have to get this. There's nothing in this class that you have to get. You can just watch, or you can use the substitutes. But if you're planning on getting some things, this would be something that would be pretty important. A lot of times you could use a meat thermometer or a candy thermometer if you have those. But if you have a lab thermometer or a science thermometer, that would be helpful for several of the experiments in this class. Then if you are doing experiments with me, I want you to make sure, this is one of the few things that I'm going to say, you really, really need these if you're going to be doing the experiments at home. You need some safety goggles, or you need safety glasses or something that will protect your eyes, because some of the things that we'll be using, if they splash in your eyes, will burn and really hurt, and we don't want that. So safety goggles or glasses or something like that are pretty important if you're doing any of the activities with me. If you're just watching, you don't need that. Another thing as far as safety, so your sheet says disposable gloves. You can use disposable gloves. I have these kitchen dishwashing gloves that work as well. So that would protect your hands if we're using some more corrosive things. So gloves could be important if you're doing some of those experiments that have the more corrosive things, like toilet bowl cleaner, for example. So like I said, you're not required to have any of this. But if you are doing the experiments, your safety goggles are the most important thing. So if you're buying one thing, that's what I would want you to buy. Make sure you keep up with the paper and that you put it in a safe place so that you can see those terms as I talk about them, know what they are, what they're called, what they're used for. So keep that in the front of your notebook so that it's easily accessible. In that same set of printables, I didn't ask you to print it and you don't need to, but this PDF shows you a list of all of the equipment that's used in all of the experiments for layers of learning chemistry. We won't be doing all of the experiments, but something really neat is that it shows you the names of the equipment and then some substitutes that you can use from home if you don't have those. So that's pretty neat. If you want to print that out or just want to take a look at it, that's in that same PDF set for Unit 1 of chemistry. So now let's get to the fun part of actually doing some measuring. So over where you wrote down measurement exercise, you can write down exactly the steps that we're doing. You can write down how much of each thing we're measuring. If there are things that are tricky that you want to remember, like how to use the mass scale or something like that, then you can write that down in this spot. So I'm going to put all this other stuff away because we're not going to be using it right now. The things that you will need for this measurement exercise are your graduated cylinder, if you have one. Otherwise, you can use a liquid measuring cup. Then you will also need an electronic balance. And if you don't have that, you can grab some measuring spoons, and I'll tell you how to measure that. Besides these things, you will actually need a little container to put on your mass scale like I talked about earlier. They didn't suggest on that paper that you have a watch glass. I like to have it. It's shallow and easy to get things off of, but a bowl works just fine. I'm going to be using this, but you can use a bowl, no problem. So then besides that, you'll need some things to measure. So what is on your list that you might want to measure? You can pick and choose based on what you have, but I have some sugar, some baking soda, some flour, and some salt for my solids. Then I have hydrogen peroxide and water and vinegar for my liquid measuring. So that's a lot of stuff. You don't have to have all of it. You can use how many ever you would like to, or none. If you're planning on doing the labs, this is a good exercise in being sure that you're careful and knowing how to measure. So I would suggest you do at least one or two of them, but this is what I'm going to use today to show you some different measuring. We'll start off with using a measuring spoon because I know a lot of you probably are going to use that. So I'm going to measure my sugar with a measuring spoon. When you're using a measuring spoon, it's really important to remember to do it precisely. So you scoop what you're going to scoop. Then you want to use something like the back of a knife to level it. And that will get you as exact as you can get with a measuring spoon. It won't be as precise as your balance, but it will be as precise as you can get. If you try to do it with your finger, it's going to go down into it a little bit. If you just scoop it, you may be over the top a little bit. So make sure that you level it off, that you fill it up all the way and level it. So that's from measuring with a measuring spoon. Then for the other things, I'm going to use my electronic balance. So for using the electronic balance, there are a few things that you need to know. So first of all, you're going to have an on button. So yours might have a power symbol, or it might say on, or mine doesn't say anything. It's just a big old button. When I do that, it turns on and you can see the display. So I'm going to go and turn it on, wait for the display to clear out. Then I'm going to put my bowl on there. You can see it's weighing the bowl, and I don't want that to happen. So I want to make sure that it says, I'm going to ignore the weight of the bowl. So I'm going to push my tare button. It's T-A-R-E. So I'll push that. And now it says 0. So it's not taking into account the weight of the bowl. Then I'm going to take my salt, and I want to weigh out 1 gram. So I'm going to put it in a little bit at a time, because 1 gram of salt is not a whole lot. And there I am, 1 gram. I do want to make sure that I am on grams and not ounces. So if you need to change that, push the gram ounce button. Some of them have many multitudinous types of measurements. So just make sure that you have it showing a G, which is the grams. If you have a more sensitive scale, which is preferable, I need to get a better scale that measures more precisely. But this says 1. You could have one that says 1.0 or even 1.00, depending on how sensitive the scale is. So you're going to put it where it says exactly 1 or exactly 1.0, or even exactly 1.00 if you have one that is that sensitive. So when you've done that, that's done. That's 1 gram of salt. Now I want to show you the difference. I'm going to use the same size bowl, and I'm going to show you the difference between 1 gram of salt and 1 gram of baking soda. So I'm going to put the dish back on there. I'm going to tare it again to make sure that it's not taking the bowl into account. So I'm going to take my spoon, I'm going to get some baking soda, and I'm going to put it in there until it gets to 1. So now it's at 1, and you can see what a difference there is between 1 gram of salt and 1 gram of baking soda. That's why measuring with a scale versus measuring spoons is more precise, because if you were to measure these amounts with your measuring spoon, they would be pretty different amounts, but they weigh the same. For our last one, we're going to measure out our flour, and for this one, I want to measure a bigger amount. So I'm going to get a bowl. I'm going to put it on there. This is a bigger bowl. I need to remember to tare between each thing. So I'm going to tare. I'm going to get a new spoon, or you can clean yours off. So now I want to weigh out 53 grams of flour. It's arbitrary. We're not doing anything with it. It just sounded like a good number. So we're going to measure again, put a little bit at a time, and watch that number go up. Now I know that that spoonful was 7 grams, so I'm going to go a little bit faster because I know I can. I'm at 26 now. Got a ways to go. 32, 48. So I'm getting close. So I need to do less at a time to get to my 53. I'm going to add a little bit until it says 53. Whoop, I got too much. I'm going to take a little bit out. I'm not going to put it back in my container because I don't want to accidentally contaminate it with something that might have been on my spoon or something like that. So you never put stuff back in the container. So I'm going to take some out until I get to that 53. And I'm good. So if you have one that's more precise, you can measure to 53.0, 53.00, but that's what 53 grams of flour looks like. So now we're going to work on doing liquid measurements. So the 3 liquids that we're going to be using are water, hydrogen peroxide, and vinegar. We're going to start by using a liquid measuring cup and measuring vinegar. So grab your liquid measuring cup, and we're going to measure that to the 1/4 of a cup. So here I have a 2-cup measuring cup. So the top line up here is 2, and I've got 1.5, 1, 1/2. And then I've got smaller measurements here that say 1/3 and 1/4. So that's what I'm going to use. If you are in a country that doesn't use cups, you can use the milliliters. This also has milliliters on the side. Either one of those is perfectly fine. So I'm going to start with the 1/4 measuring cup. So I'm going to start by measuring 1/4 cup in here. So I'm going to make sure that I only go right to that line. Don't go over, don't go under. Get as close to that line as possible. I've got some bubbles that are right at that line, but I want to make sure my liquid is right at that line. So that's just like measuring for a cake or anything like that. 1/4 of a cup, the equivalent in milliliters is about 50 milliliters. So if you want to do that and measure on the side there, you can measure to the 15 ml mark. So that is one way to measure liquids. For our next one, I'm going to use a graduated cylinder. So I have 2 measurements here. I'm going to move that out of the way. I've got 2 measurements here. I've got one that is blue and will kind of fade away a little bit, I'm afraid. And on the other side, I have one that's more, that's actually made into that you can feel on the outside. So I'm going to use my hydrogen peroxide. And for that, I'm going to do 15 mils. That's way down here at the bottom. And I want to make sure that my meniscus, which I told you I was going to explain, is at the bottom of that. So when you put something inside of a slender container, you put a liquid in there, it's not going to have a flat top. The top actually looks like this, or curved. And the bottom of that is called the meniscus. So you want the meniscus to be sitting on the line. You're not going to measure from up here or over here. You're going to measure at the very bottom. So I'm going to put 15 mils of this into my graduated cylinder. I'm just going to go kind of slow, and then I'll show you what that looks like. On the graduated cylinder, I have my 10 mil mark here. I have 20 here, and it's just like on a thermometer that you've used before. You have to make sure you know what the scale is, what each mark means. So here I have my 10, 20 is up here. I'm not holding it super steady because it's up in the air, but then each one of these is 1. So that's 11, 12, 13, 14, and 15. So I'm right at the 15 mil mark. So that's 15 mils of hydrogen peroxide. So now I dumped out my hydrogen peroxide, and now I'm going to use my water. I'm going to put some green food coloring in there so that you can actually hopefully see it a little bit better. So just a little bit of food coloring. I'm going to stir it up. And this time I want to go to 62 mils, 62 milliliters. So I'm going to start pouring in. As I get close to the 60, I want to be careful to not go over because it's hard to pour out of these very precisely. You can do it, but it's a little bit harder. So I'm going to go slowly once I get close to the 60. Then I'm going to go up to, yeah, I went over. I said not to and I did it. I'm going to pour out. Now I'm back down to 61, so I'm going to go very slowly. And there we go, I'm at 62. So if you look at that, you can see the 60 mil mark, you can see the 70, you see the 65, and then it went up to 1 and 2. Now, in this bigger graduated cylinder, it's a little hard to see the meniscus. As I'm measuring to make sure that the meniscus is at the bottom, I actually want to look down from the side. So I would crouch down and look and see and make sure that the bottom of that curve is sitting on the line. Again, with something that's bigger like this, it's a little bit harder to tell. If you have a smaller graduated cylinder, you'll see that very distinct meniscus. I don't have one with me right at the moment, but I'm going to show you what it looks like inside a test tube. Because a test tube is thinner around, we'll be able to see the meniscus better. So if you look at that, hopefully you can see there's a bit of a curve to it. So when I'm measuring, I'm going to make sure the bottom of that curve is sitting on the line that I'm measuring. So that's it for today. Next time we're going to be talking about lab safety, and we're actually going to be doing a really fun experiment called hot ice as we learn about being safe in the lab. We'll start that next time, and then we'll put it in the fridge, and it has to wait for a while. So then we'll pick it up again the next time that we meet. I'm excited about our class together, so thanks for joining, and I'll see you next time.